Hi, today we're going to work on solving absolute value inequalities. Okay, let's do a quick review about absolute values in general. We made a big show that if I said absolute value of x plus 3 is equal to, let's say, 4. And you could probably guess the x values that would make this true. If x was 1, isn't 1 plus 3 4? And the absolute value of 4 is 4, because 4 makes all numbers positive. That was an easy one. But the harder one would have been negative 7. Negative 7 plus 3 is negative 4. Absolute value of negative 4 is still 4. So we came up with a whole way that wasn't really that hard. Instead of randomly guessing numbers, especially if the problem got really hard with fractions, we said instead we could just split this into two versions, where we wrote x plus 3 equals my positive 4, like what we did before, and x plus 3 equaled my negative 4, my two different versions that are possible. Because isn't x plus 3 equal to a positive 4? What's the absolute value of positive 4? Isn't that just 4? And x plus 3 equal to a negative 4, doesn't that make it back to a positive 4? So both of these options are true. If I can make it into a negative 4 or into a positive 4, absolute values make it 4. So we said we would do the same operation, opposite operation to both of these problems. We end up with x equals to 1 and x equals to negative 4 minus 3 is negative 7. You owe me $4, you owe me $3, you owe me a lot of money. You owe me $7 now. Okay. So similar to what we had did before. Okay. Now, hopefully that wasn't too terribly hard. And you guys, when you guys went through with IXL, you realized there are some tricks. Like if I write x plus 3 plus 2 equals to 6, I don't split. I have to first clean it up. I used to joke around about zombies. You don't open the door with zombies on the outside, do you? You get rid of the zombies first, and then you can split. Once the way is clear, once you get rid of all the outside numbers, anything outside the absolute value, the problem becomes a lot easier. It becomes like our last problem. Now today, what we're going to do, we're going to shift this problem, and we're going to say instead, x plus 3 is greater than or equal to 4. We change this into an absolute value, right? That's absolute value, and we add an inequality to it. So we're pretty much going to mix the rules that we've learned for the last 2 weeks together to this lesson now. And this is the scope of your test also, including the graphing portion. Okay, so how does this change? Does it change at all? I want to remind you a couple of things. When we have inequalities, we had a rule in which if I negative, let's say 2 less than 6, negative 2x less than 6, if I divide by negative 2 across, you can see I'm taking my negatives with me across. That means we have to flip the inequality. That was a rule that we had. So when we're going to split this into my two different versions, we have a regular x plus 3 greater than, here go to 4. Does not change. Does not change. Right? And that was our positive version. That doesn't change. Our negative version, x plus 3, remember we have to flip it to a negative 4, our negative version. So here is the only new trick for the most part for this problem, is that we flip the inequality. Oops, I didn't flip it. We're going to flip it around. We still keep the equal if it's equal. If it's not equal, it's still not equal. But we do have to flip the inequality from greater than to less than, or less than to greater than. Flip negative version. we have to flip the negative version, okay? And that's the only new secret to this problem. Only new secret. We go ahead and solve the problem like we did before. -3, -3, right? That hasn't changed. X is greater than 1, greater than or equal to 1, and X is less than or equal to -7. Now, I want you to go back here and think about some answers here that would have worked. If I could plug in numbers, that would make this whole problem bigger than 4. I think you could think of a problem, you could think of a couple of answers that would work. Like 2. Isn't 2 plus 3 5? Isn't 5 greater than 4? If I pick 3, isn't 3 plus 3 6? Isn't 6 greater than 4? Are there a lot of different possibilities? It turns out any number bigger than 1 would have worked. Even 1 would have worked in this case because it's equal to, because 1 plus 3 is 4, and 4 is greater than or equal to 4. We said 2, 3, 4, 5, 6, and 2, 3, and 4 are all numbers that are bigger than 1. But would you have known that numbers less than -7 would have worked? I'm going to visually show you guys this number line here. If this is 0, -7, then -8, and -9. Aren't these all less than -7? Okay. So I want you guys to try this right now. Please plug in -8. Let's pick the number -8. And would this final answer be greater than 4? Try that. Give yourself a moment to try it. Once you're done with that, do -9 and see if that would also give you a true statement, bigger than 4. You can mental math this. I just need you guys to try it. -8 plus 3 is -5. And isn't the absolute value of -5 still bigger than 4? -9 plus 3 is -6. Absolute value of -6 is still bigger than 4. So not only do we have answers over here, but all of these answers on the right side work too. Let's draw a number line just to show all our answers. Here is -7. Here is +1. These are solid or dotted. I see that they are going to be solid. X is greater than 1 on the right. X is less than 7 on the left. Now, just as a follow-up question, would this be called an AND or an OR statement? AND or OR? As a reminder, when answers overlap, this is an AND statement. Okay? You can call me between 7 and 8 today. Call me between 7 and 8 today. You don't say call me between 7 or 8. Call me between 7 and 8 today. When answers diverge, this is an OR statement. So we could write OR here. Answers are X is greater than 1 or X is less than -7. Or. You can call me before 1 or, in this case, you can call me after 1 or before 7. Call me after 1 or call me before 7 in the morning. I'm working. Leave me alone. I got stuff to do. Okay, let's go ahead and do another one of these questions as a practice. Absolute value of, let's say, 2x plus 3 is less than 7. Okay, so question 1. The idea is, if I have to solve the absolute value, you're going to split it. But make sure, is there anything outside the absolute value? Are there any zombies outside? No? Then you can come out. 2 versions. 2x plus 3 less than 7. That's always our no change version. The positive, we just copy it without the walls. Our negative version, this is one where we split it. 2x plus 3 is, sorry, we don't split it, we flip it. This is now greater than me draw that with different colors so you guys see the difference. Greater than -7. Okay, so for absolute values, we always flip. Thank you, Walter. So we have to do a flip on that negative version. That's the only rule you have to memorize in this. It's the only rule. So to solve it, we -3, -3, -3, -3. 2x is less than 4, and 2x is greater than -10. Divide by 2, divide by 2. X is less than 2. Divide by 2, divide by 2. X is greater than -5. Now, does this make any sense? Well, let's pick a number less than 2. Let's pick 1. If I plug in 1 here, 1 times 2 is 2 plus 3. That's 5. And 5 is for sure less than 7. Yeah. Pick a number greater than -5. Okay, now this is a tough one. Here's -5. A number greater would be -4 and -3 because they're less negative. Okay? So if I pick -3, 2 times -3 plus 3, that would be 6 plus 3, -6 plus 3 is -3. And the absolute value of -3, yeah, that is still less than 7. So let's just quickly draw a number line to see if this is an and or problem. Here's -5. Here's 2. X is less than -5, but also x is greater than -5. Both of these are going to be hollow. This is going to be an and statement because they overlap. And if it's an and statement, you can rewrite it. -5 is less than x, but is still less than 2. If you don't like drawing the graph, I think the graph is helpful and it only takes me a minute, not a minute, like a couple of seconds to do. If not, here is another hint. Flip the signs so they're both facing the same way. -5 is less than x. So if they're facing the same way, you can see that this comes first, followed by this. -5 is less than x, but x is less than 2. It's almost like x is the middle child. You rewrite it as -5 less than, oh darn it, I'm not good. Less than x, but x is less than 2, right? These are the same x's, so we can flow -5 less than x less than 2. But I think sometimes drawing it out is a lot easier. You could also ask yourself this question. Are numbers less than 2 also greater than -5? Are numbers less than 2 also greater than -5? Or the other way, are numbers bigger than 5 also less than 2? If you want to think of this as time, this is 5 in the morning and 2 in the afternoon. Call me after 5 in the morning and call me before 2. Yeah, that makes sense. They overlap. Okay, let's do another problem. So let's do 3, absolute value of x plus 2 minus 5. Oh no, this is too weird. Minus 3 is equal to 12. Okay. So I see a lot of problems, a lot of zombies on the outside. So we can't split the absolute value till we get rid of these numbers. So there's nothing special about adding 3 to both sides. Please don't do this. A lot of people do this. They say plus 3 plus 3. Are we adding it to both sides or the same side here? You notice that if this is my equal sign, you just tax the left side twice. That's not fair. So what we have to make sure we do is we do it once to each side of the equal sign. Okay, 12 plus 3 is 15. Then we divide by 3 to both sides. Absolute of x plus 2 is equal to 5. Do a scan. Are there any numbers outside the absolute value? No. So I want to make this problem different now. Let's make this into inequality. Go back and change these all to less than. Change them all to less than. Change these all to less than. Okay, change all to less than. Because whether it's an equal sign or inequality, all the steps are the same. All the steps are the same till we do our split. Now we do our split. X plus 2 is equal to a regular 5, and x plus 2, oops, less than or equal to. And this is going to be greater than or equal to negative 5 until we do our split. So minus 2, minus 2, minus 2, minus 2. X is less than or equal to 3, and x is greater than or equal to negative 7. I want you guys to ask yourself without doing anything, like writing anything down. You can use the skills that we talked about before. Would this be an and or an or problem? I want to see if you guys can figure that out. Some of you guys can. Try to figure out, could I make this an and or problem right now by just looking at it? Maybe you can use the example of 7 in the morning and 3 in the afternoon. Would this be call me after or before 7 in the morning? Would this be call me before or after 3? So if I say, call me after 7, but before 3, would that work? Call me after 7, but before 3? Yeah, this would work. And if I just draw this in my number line, you'll see that negative 7, positive 3, these are both solid. They're solid because of the equal sign. Call me before 3, but after 7, this is going to be an and problem. We have to write it as negative 7 less than equal to x less than equal to 3. Okay? All right. Now we have some special cases for absolute values and inequalities, special cases. We talked about this before. Absolute value of x, would this ever become negative 2? Can absolute value ever become negative? No, no solution. The reason why we can't is because, look here, doesn't this always become positive? How can you tell me it's positive when the answer is negative? That is never going to work. Not going to be a solution for me. So the same thing happens with inequalities, but we have to be careful because depending on the situation, it could give us different results. Let's try the same thing. Absolute value of x, is that ever going to be greater? Whoops, what's in it? Is that going to be less than or equal to negative 2? Would this be a possible true statement or a never going to happen? So without even solving it, absolute gives us what type of answers, positive or negative? It gives us positive answers, right? Positive answers. And ask yourself this, are positive numbers ever smaller than a negative? Are positive numbers ever less than a negative? No, this doesn't make any sense. This is never true, so no solution. This will not happen, not on my watch. Okay, let me try to picture that. Here is, oops, that looks terrible. Here's my number line. Here is negative 2. Are there any positive numbers on this side? No, they're not less than. Positive numbers are not less than. So you could also notice that this was going to be weird. If you try to split it, you say x is less than negative 2, and then x is greater than equal to a negative negative, negative. We haven't done that before. And you would question yourself, saying, "Will that be true?" And it turns out this is a bad move. Okay, it's a bad move. You could try solving it, and actually SATs will probably trick you and give you an answer that looked right, but is wrong, because you should have stopped here. This was a bad answer already. Now I'm going to change this inequality. X, so look at this next problem. Absolute of x is greater than or equal to -2. Is this answer ever true? Can you think of a number, once you take the absolute value, that would be bigger than a -2? So let's try a number. 1. Is the absolute value of 1 bigger than -2? 2. Is absolute positive 1 bigger than -2? Yeah. What about -5? Absolute value of -5. Wouldn't that be positive 5? Isn't positive 5 also bigger than -2? So let me draw you a number line just so you guys can visually see this. Here's -2. Aren't all positive numbers? Aren't all positive numbers? Aren't they all bigger than -2? So it turns out a special answer for this is all real numbers. So like we mentioned before, absolute values can't be negative, right? That was a flag automatically. But for inequalities, since they expand the possibilities, yes, absolute values being positive can be bigger than all negative numbers. So yes, this is an all real solution. Okay, that's it.